Okay, go back to. All right, here we go. So we're starting class here with a little bit of review. Here are the questions that I wanted you to answer. What are valence electrons? What are the three types of bonds? What's the valence electron behavior for each type of bond? And what types of elements are in each type of bond? So I'm going to call on tables kind of randomly here. I want you to tell me what you found. All right, we'll start in the back here. What are valence electrons? Good, it's the electrons on the outermost ring. So most atoms have multiple rings, all right? And we are only going to count the electrons on the outermost ring to be valence electrons. There are a few atoms. There are a few atoms that only have one ring. And that is the outermost because it's the only ring that they have. And so those electrons count as valence electrons also. Bonus question Tuesday. What's the most amount of valence electrons an atom could have? Yeah. 8. Why 8? Yeah. Yeah, the electron rings or the orbitals can only hold up to 8 electrons. All of them hold 8 except for one ring. Anyone know which ring does not hold 8? Yes? The first one. The first one only holds 2 electrons. So first ring holds 2. Every one after that holds 8. So the maximum amount of electrons, of valence electrons you can have as an atom would be 8. Because as soon as you get 9, you get another ring. Because that one becomes full, you get another ring, and now you only have 1 valence electron on that ring. All right, good. Types of bonds. There are 3 types of bonds. Let me call on this group over here. What are the 3 types of bonds? We did 4 in the project, but we kind of condensed them in our notes. So if you can give me the 4, I'll take that. Perfect. All right, we have covalent bonds, we have ionic bonds, and we have metallic bonds. All right. Now, what's the valence electron behavior for each type of bond? So now when I call on your table, you can choose which type of bond you want, and then just tell me what the valence electrons do to form that type of bond. All right. We'll start with this table in the back here. What do you guys got? Good. For ionic bonds, the valence electrons transfer, meaning that they go from one atom to another. They completely leave one atom behind and they go to another one. All right, so ionic is gone. We got covalent and metallic left. All right, let's go here. What do you have? Good. Covalent bonds, the electrons are shared between the 2 atoms. So the 2 atoms, technically it could be more than 2. It could be 3 or 4, whatever. All right, but the electrons are shared in between them. All right, so metallic bonds. What happens to the electrons in the metallic bonds? We'll go here. They share a little bit differently than a covalent bond, but they are still sharing the electrons. It's more of like a hot potato game where they have the electron just for an instant and then they fling it away from themselves and it goes to another atom and it keeps getting bounced around all over the place. And that's happening to many electrons at the same time. All right, I like to think of it as a game of hot potato. Sometimes they're called a sea of electrons, or kind of this just like blob of electrons that are just jumping from atom to atom. And depending on what chemistry websites and textbooks you guys read on the weekends, sometimes they're called delocalized, which means they don't have a specific place to be. They're just kind of moving all over the place. All right, so now types of elements in each type of bond. So I'll let you again choose the type of bond and tell me if it's made up of only metals, only non-metals, or some of each. All right, I don't think I called on this table yet. Good. Ionic bonds have both metals and non-metals in them. We have to have both types, metals and non-metals, to create an ionic bond. Good. And I think this is the last table back here. So covalent or metallic, what type of elements do we see? And you get to choose whichever type of bond. Good. All right. So metallic bonds have metals only. They have metals only in that type of bond. All right. The way I remember it, metallic has the word metal in it. It's only going to be between metals. All right. And then our last one here, we have covalent bonds. Covalent bonds are going to be between non-metals only. All right. So we're going to have two or more non-metals. They're going to be bonding to each other. All right. On the periodic table, if you remember here, we have metals and non-metals have certain locations on the periodic table. So if you go from B in column 13 there, number 5, and you go diagonally down there, so B, S, I, A, S, T, E, that diagonal, everything to its right is going to be considered a non-metal. Everything to its left is going to be considered a metal. So there's more metals there than there are non-metals. All right, good review. Here we go now. When you go to Canvas, if you haven't opened it up yet, open up Canvas. A couple of housekeeping things that we got to walk through here. What's that? Oh, sorry, I thought someone was asking me a question. All right, so we have week 5 here. So yesterday, Monday's assignment should have been completed. I know in the morning, depending on how early you tried it, there was a problem with it. I fixed it. I fixed that problem, but then there was another problem with it. Yes? Yes.
I checked like 2 times and like midday was even showing it once Monday.
I know. I ran into a lot of issues and I was helping my daughter with her kindergarten work. And so I wasn't as attentive to the issues and the emails I was getting, but I did eventually fix it. Now, I did send out emails to students to try to contact you, but I also sent, and this was earlier, Friday at 7:30 a.m., I sent out an announcement with the opportunity to earn extra credit. And out of my 96 students, only 13. One of these posts is from a student who answered too late, and one of them is from me. So there's only 13 out of my 96 students who saw that announcement, or at least read that announcement. All right, that's not a great percentage. I need more of you checking your announcements and checking your emails, because that might be the only way I contact you, or the only way I can contact you in certain situations. So if you want some extra credit, because I'm going to do this periodically, all right, you click on View Course Notifications, and you can change. When I post an announcement, you get an email right away. Yeah?
I think for me, the biggest get this money is like, if you like grade something or any grade something, it sends me 4 notifications. I get 3 notifications from Canvas and then 2 emails.
So then your notifications are probably messed up here a little bit. So actually, if I go into a student view, it won't let me see it. So I got to stay in like teacher view. And so this will look somewhat different for you guys. All right, but when you go through your notifications, you should be able to see course content. That's like if I make a change, like if I write something, I'm like, oh, that direction doesn't make sense, or I misspelled a word. You don't necessarily probably need a notification for that. There are 2 ways you can go to it. So if you're on the home page for chemistry, right on the right-hand side, you should see like set or course notification, something like that. Okay. And so then when you go in there, you can change. Some things are going to be like, you guys don't necessarily need an email about it. All right. If you want to, because every time I grade something, if you want to know so you can go and check it right away, you can set that course notification. If you don't need to check it, then you don't need to set that for you. But I would say announcements should be on. Course content, I don't think needs to be on. So that's like when I post things to let you know that I posted them, which I post them every day at Sunday. So if you want to get an email every Monday morning or whatever, you could do that. Or I think if I change something. So if I misspell a word and I change it, you can get an email for it if you want. So you can, for each class, go in, but then there's also, I don't remember where it is. Maybe it's dashboard. Maybe if you go into your account. Here's notifications in your account. And I don't know if they're all going to be the exact same. They might be a little bit different. But this should set them for like all of your classes then. But for some classes, you might want them a little bit different than other classes, depending on.
Grading policies are when you give them that
no, I don't think so. I think grading policies. Whoops, let me go back here. I want to go to the grades. What does it say for grading policies here? Course grading policy change. So if I ever change the policy, which it won't change.
Oh, like how much the score is, like a word.
Yeah, so if I ever change something about the grading policy, you'll be notified. So yeah, and then grading, I don't know what it all looks like for you, but this is what it looks like for me. So you might want to change those, and then you can change it to be like immediately, or maybe at the end of the day, or you can even do it weekly. So maybe if you just want to get to see what I have graded at the end of the week, you can just get a weekly one and check it then. But I would suggest for announcements, you get that immediately. All right, because I'm going to continue to send out announcements periodically just to make sure you guys are checking them, and to also inform you. Like I posted some things. I don't remember what I did here. Some updates. Oops. So here I was telling you that the old modules will be locked down. Just kind of some reminders. Corrections and retakes were due already. We passed that. The notes, I opened that up so you can take notes now. You can go from page to page to take notes if you didn't take them in class or you were absent or whatever it was. And that late work will start being deducted here like this next week here. So some important updates I wanted to send to you. All right, well, let's get started with today's work. So Monday should now all be working. So if you haven't completed that, I won't mark it late unless you, I should say, as long as you get it in this week. All right, and that's like tomorrow, or I can even give you an extension into Thursday. You guys don't have school that day. But it's a 9-minute video, I think, with 10 questions as you go through it. So it should take you about 10, maybe 15 minutes at maximum to get that done. Okay, but you do have to watch to the very last second. So if you answer all the questions and there's still like 10 seconds left, you can't close it off or it won't record that you completed it. Okay, so that's Monday's assignment. I did update grades this morning at like 7:30 or 7:40. So things should be pretty much updated. If you wanted to go into your grades in Canvas, you'll be able to see if you got that done or not. All right, but Tuesday's assignment. All right, so we're going to click on Tuesday. We're going to click on this link to get us into Class Kick. Remember, log in and then continue with Google. And it should take you to this page. We're going to go to another website, which is going to give us a simulation of what the atoms are actually doing when they're bonding with each other for ionic bonds. So just to kind of give you a plan, we're going to really focus on ionic bonds today. And then next week, we'll really focus on covalent. and metallic. And then the next week after that, we're going to mix them all together and make sure that you master ionic, covalent, and metallic. So today, when you walk away, you don't have to necessarily be masters with ionic yet, but you should feel pretty good about ionics. If you leave today and you're like, what's an ionic bond? You need to spend some time and talk to me, maybe stay after school, ask some more questions to get you caught up. All right, so we're going to click on this link. Oh, here we go. All right, when we get to this link, you're going to log in and enroll. You might need to create a username and a password. Use a username that'll let me know it's you. Okay, so if you put, I don't know, water bottle as your name, I have no idea who that is. Put something that is your name or like your email from school. So like, I think it's your like first 5 letters of your last name and then 3 from your first name. Question? What's that? If you fill out a pass here, I'll sign it for you.
Is there a class code?
Yes, there is a class code. We are 5th period, so this is our class code, HLGKMK. HLGKMK. And then it's going to ask you to either log in because you already created an account or create an account. You guys are probably all going to have to create an account, but you have to put in some basic information, your name, maybe your age or something. Yes. HLGKMK. And then once you get through all that basic setup, you should end up here. Something that looks like this. If you're stuck or ran into an issue, let me know. What's that? What's that? So you got to put in your username and then go on class. How many of you made it to this page right here? Raise your hand if you made it up to this point. All right. Yes. What I would do is there we go. All right, if you're not quite there yet, that's okay. But I am going to go through some directions, so I want you to pay close attention, and then I'll have to walk you through how to get here if you get stuck. All right, so what I would suggest to do is kind of split screen this so you can see the directions on ClassKick as you're going through the simulation on Gizmo here, they call it. All right, so first off here, all right, we have, whoops, 2 atoms. We have sodium and we have, is it fluorine? I think it's fluorine that we start with. Oh, chlorine. Sodium and chlorine. There we go. So here's what you're starting with. The red one is sodium. The blue one is chlorine. Now, just to let you know, they're only showing valence electrons here. Remember, valence electrons are electrons on the outermost ring. There are core electrons, but they're not showing them because they're not going to affect how these atoms bond. It's only the valence electrons that affect how they bond. So even though they have these 2 rings here with nothing in them, they are really full. They're just not showing them because they don't matter. Okay, same thing here. All right, so first thing you're going to have to do is count the valence electrons. So for sodium, the red one, how many valence electrons do I have? 1. 1 valence electron, because that's the dot on the outermost ring. There's only 1 of them there. So the valence electrons are accurate. It's the core electrons that don't look accurate. They look blank here. And then chlorine, if I count these, 1, 2, 3, 4, 5, 6, 7, that would be 7 valence electrons for chlorine. And it's going to walk you through step by step on clicking play. You can change the type of elements up here. You can check to see if they're stable or not, and it'll tell you if they're stable or not here. Red will be that they're unstable. If you get them stable, it should turn blue. And then, oh, a couple things I wanted to emphasize here. This question at the bottom of page 1, it's not complete. You need to go to page 2 to read the rest of the question. Students got really confused because they didn't know how to read that because it kind of just cuts off there. But the rest of it is on page 2. All right, so you can answer it on page 2. And then lastly, page 3, you're going to be doing some kind of practicing here, trying to bond some elements. All right, so I'm going to give you guys work time to walk through here. If you get stuck at any point, please raise your hand and ask. All right, please spend your time asking questions. Don't stare at the screen for 10 minutes. That's a waste of time. All right, I can get you back on track and I can make it a little bit easier to understand if you let me know that you're stuck. All right, what questions do you have before I get you guys started? All right, work on pages 1, 2, and 3. Go.
Can I get some of my water bottle?
Yeah. No. Yes. Thank you.
This string right here is the ring of 2, or is there one in there?
You were correct the first time. That first ring you see there holds the 2. Okay. What's that? it says that the protons have to equal your electrons. Whatever you count for your electrons.
Okay, so for the fluoride, so it's got like -1 charge. Would you just put -1 for the box then here?
No, I'll put -2 because there's two fluorides. But yeah.
If I get my phone listen to music while I work, would that be okay?
Sure. Today. Yeah, it doesn't really work on Classic. But you can. I'll probably bring you guys together here in the next 5-ish, 10-ish minutes. Or if you didn't finish Monday's assignment, you could do Mondays too.
I did that one.
Okay.
Why did it just do this? Alright, what was the question you were saying? This one? It helped you
All right, you guys are doing a real nice job here. In the next 2 or 3 minutes, I'm going to give you directions for page 4. I see some of you have started it already. That's great. If you are waiting, you can either start it now and try to get a head start on it, or you can wait another minute or two, and then I'll go through the specific directions for you. Okay? So, a few more minutes here. Oh, I'm not gonna-
Okay, so you said. It's two.
All right, I'm gonna walk you guys through page 4 here. I'm gonna draw on this first one. So even if you're not there yet, I suggest that you bounce to page 4. And as I draw on it, you can copy it down. And then when you leave, I'll erase it. And then you will have that to help you in case you don't get it done. All right, so the first thing we have to do is we have to determine if lithium here, if it is a metal or a non-metal. All right, remember our diagonal line from B, S-I-A-S-T-E-A-T, that diagonal, anything to the left is a metal, and lithium is way off to the left here. So lithium is a metal. Fluorine, F, is on the far right, the right-hand side of that diagonal, and so it is a non-metal. And remember from our beginning review, ionic bonds always occur between metals and non-metals. So you should have one of each in each one. All right, now we have to do the Lewis structure. So I'm going to do Lewis dot diagrams. Remember, they start with the symbol. And then we have to do valence electron dots around the symbol. So lithium is in the first column. And remember, if we skip the transition metals, that's like SC to ZN. If we skip that section, then every column has the same number of valence electrons as their column number. So lithium is in the first one, so it's only going to have one dot. So I put a dot there. Fluorine is in the 17th or the 7th one, if we skip those intersections there. So it's going to have 7 dots. 3, 4, 5, 6, 7. All right. Now, I need to show valence electron behavior. And with ionic bonds, it's always a transfer. And so I need to transfer electrons here. Can anyone help me? Which way are the electrons going to transfer? Are they going to go from F to Li or from Li to F? Yes. Okay, good. How'd you know that? Good. All right. Fluorine is 1 electron away, so it's going to rip that one away from lithium. And also, we always go from metals to non-metals. So the metals always give them away. So this one's our metal. It's going to give it away to fluorine. Now, we just have to double check to make sure everything's working out here. Fluorine now has 8 valence electrons, so it's good. It's stable. Lithium loses that one, but has an inner shell that is now full as its outer shell. So it's good. And then we're just going to write the formula LIF. Okay. Now there's a there's one Li, there's one F. We usually don't write ones in formulas. I'm not going to get real picky with the formulas because we haven't talked about them yet. So it's LIF. But let's say, for instance, there were 2 LIs. I need to put a 2 after this one. And even if you don't put it as a subscript, which means it's like below the letters, even if you just wrote it like this, L2F, I would count that 100% correct for right now. We haven't spent any time talking about formulas. So I just really want to see how many of each atom you have. So here's 2 L's. Sorry, I put it after the L when technically it should be after the I. Just so you're not too confused, let me fix that. All right, so that would be like 2 LIs and an F. Or maybe I have, in some cases, I might have 2 Fs. And so then I would put my 2 after the F. I want you to essentially tell me how many do you have of each atom. Okay, the order and like the kind of specific requirements, I'm not going to focus on because we haven't talked about it yet. We'll save that for a different day. Okay, now as you go down here, some of them get trickier and trickier. Some of them you need to transfer 2 electrons. Some of them, remember for ionic bonds, you might have to add extra atoms. So in some of them, you might have to have like maybe 2 calciums and 1 chlorine, or maybe 1 calcium and 2 chlorines. Some of them you might have 3. All right. I think this one right here, I think is the toughest one out of all of them. And same with We go to class kick, page 3. This last one here, this is the toughest one. The tough ones are going to have 2 of one atom and 3 of another. All right, 2 of one atom and 3 of another, and you have to figure out which ones they are. All right, so I'm going to start erasing this now. So if you haven't copied it down yet, make sure you copy it down. But page 4 is going to be pretty much the same thing as the end of page 3. If you want, so you can draw them on your screen. Some students ask, can I sketch it on a notebook and then take a picture, and then you can just put it right over this section? You can totally do that if that's easier for you. If you can get it done faster, writing it out, taking a picture and putting it up here, do that instead. That's fine with me. All right, erasing time. Okay, I think I got everything there. All right, we have 25-ish minutes left of class. If you get pages 1, 2, 3, 4 all completed, export, submit on Canvas, and then you can spend the rest of the time either completing missing work, fixing errors on past assignments, working on other classes, and if you show me that you submitted, I'll even give you the option to use your phone today. It's a big deal. But the rest of the time is yours. All right. So keep working hard. You guys are doing a great job. If you follow the pass, I'll sign it for you. Here you go.